Wow! I've been looking over your whiteboards, and you guys have found so many ways to prove that 7 times 4 equals 28. Here's how Moira saw it. I added some Cuisenaire rods to show. She saw that 7 times 4 equals 28 means 7 fours. Each of these pink Cuisenaire rods is worth 4. 1, 2, 3, 4. So she writes 4 plus 4 plus 4 plus 4 plus 4 plus 4 plus 4 would be just like adding up 2 4s together to make 8. She puts together 2 4s. She puts together another 2 4s. That makes another 8. Puts together 2 more 4s. That makes another 8. But then, since there were 7 4s, 1 4 doesn't have a partner. So you would just add on 1 more 4. Let's see where she goes from there. She sees that she could put together 2 8s. And those 2 8s would make 16. But then she doesn't forget about the 8 that's left here and the extra 4 that didn't have a partner. So she adds up 16 plus 8 plus 4. And when she adds up all these 4s, oops, 16 plus 8 plus 4. Well, I know that 16 plus 4 equals 20, and 20 plus 8 is 28. Here's Mary's notebook. She says 7 times 4 is 28 because 7 plus 7 is 14. 7 plus 7 is 14. Notice 4 sevens. And 14 plus 14 is 28. See these black Cuisenaire rods? They represent 7. See how there are, if you look carefully, you see almost like there was 7 cubes in each. 1, 2, 3, 4, 5, 6, 7. Each of them has 7. So Moira said 7 plus 7 plus 7 plus 7. That's 4 sevens. And then she added up 2 7s at a time. So for the first 2 7s, if you put these together, it's 14. 7 plus 7 equals 14. And then the next one, 7 plus 7 equals 14. So now, if you put that together, it's 2 14s. 14 plus 14. And here's what that looks like, all put together. 4 7s makes kind of a rectangle, right? 7 plus 7 plus 7 plus 7 equals 28, which is the same as 14 plus 14, right? 2 of these would be 14. And 4 and 4 is 8, and 1 and 1 is 2. So you just proved that 7 times 4 equals 28. So you could look at 7 times 4 equals 28 as 7 fours. 1, 2, 3, 4, 5, 6, 7. Or you could look at them as 4 sevens. Just like addition, if you change the order of the numbers, it doesn't change the answer. 7 plus 7 plus 7 plus 7. Look at what Paul did. Paul told me he was thinking, how the heck am I going to add up all those 4s? When he realized he could just switch it around. Instead of having 7 4s, he could easily have 4 7s. And read what he wrote. I think because 4 7s take 2 7s, it makes 14. Same for the other 7s. So what he's saying is 4 7s can be split up into 2 7s and another 2 7s. And when we put parentheses around the 7s, we know that we want to put them together. 14 plus 14 equals 28. Well done.
Look out below! Hey everybody, good to see you again. Here's how I thought of 7 times 4 equals 28. Here's my board, guys. Does it look like any of your boards? Oh, is that your board, Parker? Hey, I think we did the same thing. And Ben, look at that. 7 plus 7 plus 7 plus 7, just like I did. Hey, Eden, looks like you have 7 plus 7 plus 7 plus 7. Hey, Mayru, 7 plus 7 equals 14, and then add the 14s. 14 plus 14 is 28. Hey, that's just like I did. Oh, hi, Aiden. Look at that. If 7 plus 7 equals 14, and 7 plus 7 equals 14, then 14 plus 14 is 28. There's 4 7s there. Lorenzo, what? Oh, because 7 plus 7 equals 14, and another 7 plus 7 is 14, and 14 and 14 is 28. And Talia, wow, that's like a carnival ride. Wow. I see. 4 plus 4 plus 4 plus 4 plus 4 plus 4. And you counted 7 4s. I did 7 times 4. I did 4 7s, but you did 7 4s. Oh, yeah, second grade style, because you're adding. Here's Ansley's board. Let me look. Oh, I see. She added 4 plus 4 plus 4 plus 4 plus 4 plus 4. But Miles did 7 plus 7 plus 7 plus 7. So she showed her own way, and she showed Miles, and she said, Miles looked at it differently than her. What a great way to say it. Anybody else want to show me their board? Hey, Brianna, can I see your board? There's Brianna's board. Let's see. Hey, she did it like I did it. 7 plus 7 plus 7 plus 7. Then 14 plus 14.
Hey, little Lizzie, did you know that that kind of thinking has a name?
Yeah, it's called SMART.
Well, it's smart, but mathematicians call that kind of thinking repeated addition. Repeated addition is one way you can think of multiplication. Every multiplication problem is the same as an addition problem. Today, you're going to play a game
A game? A game? A game, a game, a game! We're playing a game! We're playing a game! I love to play, love to play, love to play, love to play! I love to play games! What do you play? How do you play? How do you play it? Where's the materials? Where's the fun? Where's the... Ow! Okay, I'm listening.
Thank you. Okay, here's how you play. You'll have 2 regular die. That's the ones with the dots on them. You'll roll 1 die. That should say die. You'll roll 1 die, and the number I roll will be the number I'll make a repeated addition sentence with. So my numbers are all going to be 4s. Then I roll again. The number you roll this time is the number of times your number will repeat. So this time I rolled a 2. So now I know I'm going to have 2 4s. 4 2 times. 4 plus 4. Let's see how that's going to look on the game board. I rolled a 4 and a 2, so I color in 4 squares and 4 squares. My partner rolls a 2 the first time and a 3 the second time. So he's going to be using 2s, and he's going to have 3 of those 2s. So his addition sentence would be 2 plus 2 plus 2 equals 6. He would color 6 squares. So he colors 2 plus 2 plus 2. 1, 2, 3 2s. 1, 2, 3, 4, 5, 6 squares. And so on until you get as close to 100 without going over. Now, you may have enough time to play to 100 and you may not today, but tomorrow you'll have a little more time.